that can, or in multiple languages, any language that supports compiling to WebAssembly you can do, but the best support is for Rust, currently at least. And so you will write a smart contract in Rust, then you will compile to WebAssembly, and then you will put this module on the chain. So the life cycle of a smart contract is that you deploy this smart contract, this WASM module that you've compiled onto the chain, and then afterwards, that is sort of like putting a class in object-oriented programming onto the chain, and then afterwards you can initialize it. That is similar to creating an instance or an object from a class. So you can do this multiple times, and then you get different instances, which each have their own state and data. And then after that, each instance can be updated a number of times, and anyone can try to update instances. But of course, you can include some logic in there to say that, for example, it's only you or it's only these 4 people that are allowed to actually do certain things with your smart contract instance. Okay. So now let's look at now we know a bit about Concordium. We have this ID layer, which is quite unique. And we have we have smart contracts that you write in Rust and then compile, and then you can put it on the chain, and that's what we'll do. So now we have to solve some problem. Imagine that this is you, and you like singing, you like music, you like contests, right? And you just seen this commercial on TV saying Eurovision is coming to Asia. Eurovision is this song contest, singing contest, as you might know. And you become really excited, and you think, of course, I'm going to vote on my own country, right? Because that's where, no matter what, I'll just vote on my country, even if, because I just want my country to win. Right? So maybe some of you in India would say, I would vote on India. But that's not how the rules are in Eurovision. You're actually not allowed to vote on your own country, because that would be unfair, because a large country would have much more votes than a small country. So currently, at least in Europe, the way that it works is that the way that they check this is when you call in and want to vote, then they check the country code of your phone. But of course, that can be spoofed. You can also get a phone from a different country, and then suddenly you can vote in your own country. You can also vote with an app where, but that can also be cheated, right? And then you can vote on your own country. But then you get an idea. What about Concordium and its identity layer, its ID layer? Because if you recall, when you got an identity, it said something about your name and your date of birth and your country of residency and country of nationality. And this information is actually put encrypted on the chain, so no one else can see it, but you are actually able to use it to prove things using something that's called zero knowledge proofs. And that's a very cool cryptographic thing that you can use, which allows you to say, prove certain things. For example, I am not from India, without revealing that I'm from Denmark, for example. Or you can prove I am older than 18 without revealing that what your name is or how old you are. So you only prove the one little thing that you want to prove. And you can do that using the Concordium blockchain. Okay, so now we're ready. We have this idea, exhibition. We want to do voting, but you're not allowed to vote on your own country. And let's do something like that. With that, let's first build a voting smart contract. And this voting contract we will initialize with some voting options. For example, which countries are in this election, or like, is it Asia, or is it European countries, or which countries are in there? And then an end time, what is the final time for you to vote? And then maybe some description about what the election is about. Yeah, and after you've initialized it, anyone will be able to put in a country code and then vote on your contract, so one of the voting options. But this is where we have the same issue as before, right? Anyone can vote. Here there's no checks even. So what we want to do is that we want to check the here. We want to what we want to do is that we want to check the country of the voter off chain, meaning that it's some programs that are not running on the chain. So smart contracts are running on the chain. So there's this distinction in blockchain. So we want to check this off chain, and then we want to do one of these magic zero knowledge proofs that will then return some signature, and then this signature can be checked in the smart contract. This is a bit complex, and we won't actually do this part in this tutorial. We'll do something simpler, but that we can get all the way done with. And then if you're interested in making like a real system, then you'll have to do a few extra steps. So what we'll do instead is that we will still check off-chain with your country, and then make a zero knowledge proof and say that the front end just enables or disables a vote button based on this whether you're allowed to vote. So these two parts will not be included in this tutorial, but they are fairly easy to add, and you can always write to us afterwards. Then we can help you build those things. Okay. So I won't show how to install all the things. We have a good documentation for that, but I'll just show what is needed for this tutorial, which is you need to have the Rust programming language, and then the Concordium browser wallet, and that's Doris will go through that and show how to set that up and create an account and identity, and then from there you can then get export the keys for Concordium client, which you will also need, which is like a command line tool for talking with the chain, and then Concordium, which is like a tool for smart contracts. But we will send out these slides afterwards, and then you can look this up. Okay, so what we're going to do is we're going to start writing the smart contract. So let's first go and create. So now we have Cargo Concordium, which is this thing. And with that, you can, is it large enough for you to see, or should I zoom?
Yeah, it's better now.
Okay, yeah. Okay. So with Cargo Concordium, you can set up a smart contract with a default from a template, and you can do that like this. And then you can choose which template, and you can have NFTs, which is kind of like it's if you've seen something about NFTs with digital art and these sort of things, then this is the area or template you can use. But we will just want the default template. Then we will give it a name, and let's add some description. Okay. And then let's put it here. So what we got was we got this cargo.toml file, which is similar to package.json in JavaScript, if you know that. And it includes the Concordium std, which is our package that you use for writing smart contracts. And then you also get a lib.rs, which is the file. Let's build some, get some thousands. Okay, so this is like the initial starting point, and I would recommend that you also use this template or one of our other contracts to as a starting point, because that's quite a lot easier. I get intelligence for this. Yes. Okay. So the first thing we're going to do is we want to define our input, right, as I showed. So let's create a new structure. You can just ignore everything down here for now. So we'll create a struct called init parameter. A struct is like a group of data. And if you recall, there were 3 things that we wanted when you set up a new election. There was a description, which is like let's use a string here. And then we had some options, which will be a vector of strings. Actually, let's call it a voting option. And then say that a voting option is just a string. So this is just an alias. So here we're saying that we want a vector of voting options, which are just strings. And then we have an end time, which is a timestamp. Okay. Now, I will, so this template included like a state and something about errors and an init function, which is like a constructor function. And then also a receive function, which is like a method on a class or object. And then also a view function, which I'll get back to. And then also some tests. So I will take this init function that we got and put it up here. So we have this. This is just a regular Rust function, and here we annotate it with this init attribute, which is something that is specific to Concordium. It just wraps the code a little bit so it works on the chain. It doesn't do very much, but it does so it's easier for you to write your smart contracts. So here say that this is the init method for the contract voting. And the init method has 2 parameters, a context, which has some information about like who is trying to initialize this contract and what time is it and these sort of things. And then it has a state builder, which you can read more about in our documentation. It's for creating more complex state. We won't be using that. And this init method is generic on the state, and that's because we want the ability to test your code, and then we do this sort of dependency injection, if you know what that is. But it's just we make the functions generic, so they will work with the actual chain that is on the blockchain, but also so it works on this test state that we will that we can use. And this init returns a result, which is like an enum, which is like an option, an enum, where you can have either okay, and then it returns a state here, or it can return an error and then some error. So it's like an enum where you have 2 options, either it returns okay or it returns an error. And all of these functions will return will return results. So here we're saying that it returns a state. So that makes sense, right? When you initialize a contract, then you end up with some state that is now the contract state. So what should our state be? Let's try to define that. We have this empty state down here. But at least we want the same things as our initialization parameter, right? So a description, some options, and end time. The contract should be able to know these sort of things. So let's try to make this work. So we want to first get the parameter, which is the init parameter, which is this type up here. And the way we get that is by getting that from the context. So we're when a smart contract is invoked, it gets some binary input, some binary data as a parameter, and then we can deserialize that, like so. So here we're using a question mark, and this question mark is interesting because if you see at IntelliSense is not working. Oh yeah, so you can see that this get method returns also a result. Again, something where it succeeds or it fails. And here with this question mark, I'm saying that if it succeeds, just take the good part out and then give it back to me, which is the init parameter. And if it fails, then terminate this function early, like return a init result. Okay, so then we have the init parameter, and then we can create a state from that. We can just say that the description is the description, and we can say that the options is the param.options, and we can say that the end time is the param.end time. Okay, that's pretty good. So now we have an init function that should work. But we should probably also have a way of counting how many votes and who voted on what. We will do that with a map. So a map from accounts to votes to selected voting option. Yes. Let's call that ballots, and we will use a B-tree map for that. So, and we'll say it's from an account address and then to a voting index. So we will keep a voting index, which is like a number, into an index into this vector of options. We won't keep the string. Again, we'll just index. Let's say that's a U32. Okay. And then we also need to initialize that thing, the ballots. So we'll create a B-tree map. We probably need to import this. Yes. Okay. One second. Okay. So then we have this initialization, and we will, if we just stop our contract here, then we can actually initialize our contract and get a valid contract. That's pretty cool. Except that it's super boring. You cannot do anything with this contract. So let's now do something more interesting. Oh, it gives me a warning that we do not know how to deserialize this init parameter, but we can luckily derive that. So we can say that it should be serializable. That means that we should be able to go from this code, this data, into binary, like a lot of ones and zeros, and then also the other way around, because that's what's happening here. We're getting binary, and then we turn it into this init parameter. And then we say we also want it to implement a schema type, and we want that because I won't go into details with that, but you can read that about it on our documentation, but it allows us to do this trick, which allows us to use JSON to provide to write the parameter as JSON, which will look almost like this, like this, instead of writing binary when we call the contract. Okay, so now we're getting to the interesting part. We will go to create a voting function. So I'll just put this up here. Okay, so we have this init init thing here, which constructs which is like the constructor, and then we have receive functions, which are methods on the object, i.e. methods on the contract instance. And let's call it vote. And let's say that the parameter that you specify should be a voting option. Remember, that's like a string. For example, it could be in or dk or something like that. And then it returns an error. Again, this is something with JSON that I won't go too much into. And then we say that it should be immutable. And that's because we want to be able to change the state here. So when someone votes, we should change the contract state, say that, oh, now we have one more vote, or maybe someone changed the vote, so we should be able to change that. Let's call it vote. And again, it returns a result, takes in a context with some information, and it also has a host. And again, it's generic, so that you can do some testing of this function. Let's remove everything else here. And then let's say, what do we want to do? We want to check, the first thing is that the election hasn't finished. That's the first thing. Then the second thing is that the sender is an account. And that's, I mean, we could do something where we allow contracts as well, but here we're trying to keep it simple. So we're just saying that only accounts can vote. And we are, what else do we want to say? Voting option is valid, i.e. it exists in the state.options vector. And then we want to do update update the vote. And then we want to return success. So this is what we're going to do. So election hasn't finished. Okay. So the context has some information about what time it is when this function is called, like this vote function is called. So let's say what should we say? If the context metadata of slot time, if that is, so if the current time is larger, then
we can't see your desktop.
Oh.
Kasper, we cannot see your display.
Yes, I don't know why, but I'm aware. I lost connection to the internet, it says. Okay. Okay, a brief break, I guess. Okay. We good? Yes,
Yeah.
I can see myself at least. Okay, so let's say if the current time is larger than so the host has the state, the end time, then there's trouble, right? You're not allowed to vote after it has finished. So we want to return an error. And this error, we want it to be a specific kind of error. Voting finished. So let's give a good descriptive error. So we can use this here. Voting error. Let's call voting error instead. And then, so this is the parse error. That's the one that's being returned by that question mark when we try to read the parameter. And we don't need this error, but this is, as you can see, this is an enum. So it's like a different It can be either one thing or the other thing, or whatever option it is. Cannot be both. So let's create an option here called voting finished. And now that part is done. So we can say that we're not allowed to vote after end time has been reached. We also want to check that the sender is an account, and we actually also need the account address. So that's what we'll do next. So let's say match. So match is like a switch statement or a case, you know that. Match on what do we want to match on the context of sender. And that is an account, address account. If that's the case, then it has this associated account. And then we just return the account. But if it's a contract, then we don't really care about the contract address. We just return an error. Again, voting error, or say contract voter. That's not allowed. And we will go down here in the bottom and add a contract voter error. Okay, that's pretty good. Oh, thank you. Okay, the next thing we want to do is that we want to say that find out whether the voting option is valid. That means that it exists in the state.options. So what we'll do is say we want to get that out, vote. We first need to get the new vote, which is a voting option. And again, we say with the context parameter cursor gets, and then return a question mark here. And that means that if it's a fail, if we cannot pass this as a voting option, then we return this error early. Like we just abort the whole function. And then we want to get, so that gives us a string here, and then we have a list of strings, which are the voting options. But we want to find the index in that. So for example, if this is in, maybe ge, and state.options is like this, then we want 2 to be returned, because this is 0, this is 1, this is 2 in the list. The way we get that is we say new vote index, create a new variable here, and then we say host.state.options. And then we get an iterator into that, and then we say position, and then we're saying if we can find the position where this so loops, it's like a for loop, loops through. So if we can find something where this O, which stands for option, is equal to this new vote, then return that. And actually this ends up returning an option, which is like this enum option. It's where it returns some X, or it returns none. And this is also generic. And here we want to say that, so if we can find this new vote inside this, inside our options vector, then we're good. Otherwise, it's an illegal vote. So here we're actually matching this again. And we're saying if this is some index, then we'll just return the index, and we'll also convert the number type. And then if it's none, then we'll return an error again. Error, voting error, invalid voting option. And then we will have to add that. So someone tried to vote on, like in this example, someone tried to vote on, I don't know, China or the US, and that's not allowed. Okay. And then what else do we have to do? Add or update the vote. Okay, so now we have this index. And then we can say post state mutable, because now we want to change something in the state, so we need to get a mutable access to it. And then in the ballots, which was this map between accounts and then the voting index, we want to get an entry for the account. And an entry is, it's like a nice way of finding the, if you know something about tree structures as a data type, then you know that, for example, if you put something in, then it has to be in a specific location, for example, a min-max tree or something like that. And this is a B tree, so an entry here will give you either the value that is on this position for this account. So if the account has already voted, then we will get that back, or you will get a position, the position where you can put in new information. So if the account has never voted. So here we have some helper functions where we can say and modify. So we can say the old vote. We're now setting that to, so this is if the account has already voted. We're setting that to new vote index. And we can also say or insert new vote index. So account never voted before. Okay. And then we want to return success. Boom, boom. That's it. Okay. A bit short on time for this. So I will just copy over the view function, and there is some information in this example which we will share later. It's just so we have time to do all the things we want to do. I actually put it on chain, but we will give you access to the repository where all the code is. Okay, I think this is good. Yeah, so what it does is that we want to return a voting view. We can just create that voting view, which includes a description. So this is like a special function that or it's just a function, but that the front end will call to get some information about the contract. So it will also include the end time, which is a timestamp, and then it will include a tally, which is a B-tree map again, but now we don't really care about who voted on what. We just want to say for each voting option, how many votes did that one have? And the voting view. Yes. And then we want to be able, then we should say that it's serializable, serialize, and schema type. I think that's it. Okay. So yeah, so this just loops through all the votes and then inserts it for like for each account. It tallies up all the numbers and then creates a map that looks like this. And there, in the example code that we will share, there's also some correct tests. These are just to generate a default test. Okay. So I see that we have some probably some small errors. So I will cheat a little bit because I don't think we have that much time. So I will just go into this smart contract. It's identical code basically. This is the one that we will share. Okay, so what we want to do now is we want to deploy build the smart contract, deploy it on the chain, and then initialize it and update it. And then use that view function and see that everything works. So what we're doing is we're saying cargo Concordium build, and it has a few different options. So you can see it has this notion of a schema, which is like some information that is used to convert between binary and JSON back and forth. And we want to have that embedded in here so that it lives in the blockchain. So it always we always have this way of converting back and forth. But for the front end, we also needed to have it get it out as a file. So now we're going to say cargo Concordium build, and this will turn our Rust code into a WASM web WASM module that we can then deploy. And then we want to say so out a that wasn't you on. We just want to say this is the WASM module, and we want to say schema embed, and we also want the schema out into schema.bin. And then let's build it. And now we can see that it's built, and the WASM file lives here. And then we can use Concordium client. And for this to work, we need to communicate with a node. So one of the computers that are in the network. And we will do that. We've opened up one that we are calling shebuilds.concordium.com. So we can specify that, saying Concordium client, please talk to a node that lives here. And this one will also be available in the weekend, but after that, it won't be available any longer. We are working on something that can be running always, but at least for the weekend, you will have access to this. Otherwise, you can run your own node, which is also, there are installers for all platforms for that. Okay, so what we're doing is that we're saying module deploy, and we want to deploy this a.wasm.v1, and the sender is this account that I've called K. That's just an alias, and we can see that it costs 40,000 energy, and that this energy is used because when I send something here and this adding new data to the blockchain, then all the nodes that are in the network has to process this information and say, oh, someone added a new smart contract module. And of course, that costs a little bit of money in electricity. So we have to pay for this. As like my account has to pay for this and get it, to get it on the chain. But luckily, it's not very expensive. I think it will cost like $50 or something like that. And so let's confirm, and then here, and now we're getting some information about it being committed. Oh, and then you're only allowed to deploy a module once, because a module is like a class, so you can only have the same class once. But usually you won't run into this problem, because when you compile it on one computer and another computer, it will differ a little bit. But because I tested this already, it's already here. But it should show up something like that transaction succeeded, and it has this module reference, which is like a reference to this specific WASM module on the chain. Now, the following things we can do again, because of course you can create multiple instances of the same thing. I am done in 1 minute, so there will be time for some questions. Yes, that's a good question. The gRPC IP is for testnet. So we have a mainnet, which is like the real thing where things actually have value. And then we have a testnet. And we have a testnet where you can get free money on to use and play around with. All right. So the next thing we'll do is that we will initialize this contract, and we will say the sender is again me, and here we will set some limit to the energy, and we will say a parameter, which will be this init, and then we'll say the contract voting. And the reason why I'm setting this this energy limit is because it could loop forever, the contract, and I want to set a limit to try to run this function, but you cannot use more than this amount. Like I won't pay if it costs more than this. And just to show that the thing that I'm giving it, I'm giving this this JSON file description and options, and then end time, and then we can what can we do? We can do contract show. So we got out from this one, and then we can see some information about the contract, and we can do contract update. And here we are saying we want to update our entry point vote. So we want to make a new vote, and we want to say the sender's K, and the energy, again, we set some limits, and we say the parameter as a JSON file is this vote.json. And we should see that succeed. And you can see the vote.json is just this file with in being included. And we can see that this succeeded. And then in a second, we finalized. Okay, and then we can say the client, and then we can say contract invoke 2390, and we can call the view entry point that we created in the end, which went quite quickly. And we can see that the description is here, and this is the end time, and this is just tally. So India has gotten 1 vote. Okay, that was a bit quick, but I wanted to have time for a few questions. There are some more details here, additional resources. We will share these, a link to these. And now we have time for questions. So I hope you enjoyed it. Let's see.
Hi, Kasper.
How do we do, Chris?
Hey, folks.
Do people just call out?
You can ask
or do
questions
they-
one by one.
Okay.
Yeah, and you can
Eh,
also write in the chat box if you have any questions. Okay,
Okay.
Kamal, go ahead.
Hi, Kasper. So, my name is Kamal, and I'm a blockchain developer, and I basically work with Solidity. So, my question was that can we use Solidity for writing smart contracts on Concordium, or it's
Nope.
just Rust?
No,
Uh,
it's not possible. But we do have some. So, like, it's not possible, but we do have some information for Ethereum developers. A lot of frequently asked questions here, which is on our developer documentation, which is on developer Concordium software. So even though you cannot write Solidity, I think you will already have a leg up on writing smart contracts here. And then we have a lot of information that will get you started. And we also have tutorials in here and a quick start guide and how to write tests for your smart contracts and tutorials and these sort of things. So this is basically the way to go.
So, do I need to run a node software on my computer to make a dApp work?
No, not during this hackathon, because you'll be able to use the CBuild Concordium node.
Okay. So, the identities that are created, they are verified by the identity providers, right? So,
Yes.
what if I give my fake name, so that won't get verified, right?
No, that won't work. You have to provide a valid ID. And there are
Even
some
on the
specific.
even on the testnets.
No, on testnet we have a special fake identity provider where you could just create some random, where you can specify things yourself. So you can say that you're from another country, and it's called John Doe and these sort of things. Yeah.
Okay.
And you will see that if you use your phone or on the browser wallet or desktop wallet. Okay, more questions?
Yes, you said Concordium uses the ZK knowledge proofs. So, what kind
Yeah.
of ZK technology that Concordium uses? Is it ZK Snarks or ZK Stacks? What it is?
So I'm not an expert in zero knowledge proofs, but I believe we use CK snarks. I can get back to you on that. If you write something, then I can put you in touch with
Sure,
or you can
definitely.
just write to support or something. Then we can get back to you. But yes,
Sure.
I do believe we use CK snarks and probably a few other things.
Yeah, thanks.
Yeah.
Yeah, Ankush, go ahead.
Hello. While you were deploying the smart contract, you ran 3 commands. One was for
Yes.
the deploy, and after that you ran the update command. Could you elaborate on what the update command does?
Yes. So I think it's easiest to just go back to this slide. So what we did was, the first thing was deploy. So we put the WASM module onto the chain, and the WASM module was that code that we got out from compiling, and that is like it includes the smart contracts, but they are not active yet. It's like a class in object-oriented programming. And then afterwards, we initialize the contracts, so we get an instance of it or an object of a class. And you can do that multiple times, but then you get multiple different instances, which each have their own state, and also each have their own address. And then you can update the instance a number of times. So, for example, here we updated it with a vote, and then we changed the state of this specific smart contract instance. So those were the 3 major things that we showed. I also showed a view in the end, which is not a transaction on the chain, but it's just a way of calling a specific function from a smart contract to get some information out. And that was the last thing where we got out this information here. Yeah. Did that answer your question?
Yep. So initialize creates a new smart contract and generates a address for it, and updates the same contract which we generated the address for as many times as we want, right?
Yes. And like it does whatever your receive functions in the contract specifies that it will do. Right. So you can also say that only the owner of this smart contract can say that only the owner can update it or something. You could write your own logic. We also wrote our own logic saying that only accounts can vote, right? So you can do what you want in there.
Okay, thank you. And is there a block explorer for the she-builds testnet?
Yes, there is. So we have 2 different ones. We have this one, dashboard.testnet.concordium.com. And we also have, what's it called like this? testnet.ccdscan.io. Yeah, and you can, maybe these are ours. Could be 8 minutes ago. Could be us. Yeah.
I mean, is this testnet different from the one we are using for she-builds?
No, this is the same testnet. You're just on we just have one testnet and one mainnet that is public.
Okay, thank you.
What is Baker in Concordium, and CCD means Concordium, right?
Yes, CCD is also the coin that we have, the token.
Token.
Yeah.
And what about Baker?
So that's like what is it called on Ethereum? It's like the nodes that will actually produce blocks. It's the miners.
Yeah, miners.
Yeah, but Concordium uses proof of stake So it's more eco-friendly in that way. It uses like nothing compared to Bitcoin or the old Ethereum. Yeah.
And the gRPC normally is Google remote procedure call, right? Is it the same here? Like you
Yes,
write in the
that
command
that is
minus.
the API that is used.
What does your command mean? Like if you can go to that where you had written the command grpc minus minus grpc minus IP. What does this command actually mean? Like you're writing in the Concordium client.
So here I'm saying run the Concordium client tool that we have, and like you can also get some more information about it. And then we say this gRPC IP, it's which node should I talk to? Because Concordium client primarily talks with a node. So I want to say which node should I talk to when I want to send transactions or want to get some information from the chain. And here I'm getting this shebuilds.concordium.com. I mean, you can also specify your own contract, your own node or an IP to your friend's node or something. Here we just created an URL for it, which is easier to use. And then from here, we have some subcommands like contract. And contract you can do like a show, or you can list contracts, or initialize a contract, or update, or invoke. Yeah. Did that explain it? There is generally quite a lot of documentation, both in the tools. We try to be really good on that. And we also have on this, it's really developer.concordium.software. That's the place you should go as to get started. When you go there, it will look like this. It will look like this, and this is like different chapters into this book, or links into this book, but it's all the same book. So it doesn't matter so much which one you click, but those are just shortcuts.
You can find a link to that in the chat.
Yes, good.
Hey Casper, this is Sailesh.
Hey.
Yeah, actually, I wanted to ask you that what kind of optional attributes do we use in order to change the required signature to include an extra augment type of amount, which allows the function to access the amount of CCD supplied with the transaction.
Sorry, I didn't get that. The amount?
Actually, I wanted to ask you that which kind of optional attribute, like what are those optional attributes do we use in order to change the required signature to include an extra augment of type amount, which actually allow the function to access the amount of CCD supplied with the transaction.
To make it payable?
Yeah, it is. Yeah, well, that's what I was
Yeah.
like. I want to get assured with. Got it. Thank you.
Yeah. Yes. Like so say if you wanted to say you have to pay some amount of CCD to vote, then you can make it payable, and you will have an amount here. And then if you say if amount less than 10, okay, we can do that from CCD 10, then return an error, voting error, insufficient funds, right? Then we would have that. Then there we go. So now we have to pay 10 CCD to vote.
Fair enough. Thank you. Thank you so much.
Yep. More questions?
Yeah, more questions. If you want to ask question, if you are unable to unmute yourself, you can ask in the chat as well.
Yep, so I have one more. So Casper, when you say that you are updating the contract, we know that the contracts are immutable on blockchain. So when you are updating it, so are you creating a new instance of the contract, or are you updating in the old contract itself?
So contracts are, they are not immutable as such. They, like, you can always go back in history and find the state of a contract. But you do update the contract but you can always go back and find the old state of the contract. So it's like you have the whole timeline of how it's updated and how it changed through time. So you don't create a new instance. I mean, you can create multiple instances, but if you just update one instance over and over, then it will change the state of the contract. But you will always be able to go back to say, okay, what was the state? How many people voted at I don't know, 10 minutes ago? You will always be able to do that.
Oh, okay. And thank you.
Yep.
I'm not able to see any more questions in the chat. So yeah, thank you so much, Kasper, for this amazing session. And yeah, this is very amazing session, folks. So as you all already know that we are also running a hash note giveaway where you can write blog of your favorite session or just the summary blog of all the sessions. So you can write blog, tag hash node, you can tag Concordium as well, and hashtag SheBuilds. Top 3 winners will get hash node t-shirt. So yeah, thank you so much for this insightful workshop. And also I just shared the giveaway link. This is a random giveaway, and here is the link of of the website and the Dayfolio link. If you have already not registered for the hackathon, go on this website and register for the hackathon. And yeah, so yeah, thank you so much, folks, and thank you so much, Kasper.
Yeah, thank you,
Yeah,
Kasper
thank you.
and Doris. Thank you so much. Really had a
Yeah.
great time with you all.
Yeah, you're welcome. And I'll see you people in the weekend where we will also be available for support. So yeah, good luck with your hackathon.
Thank you, Kasper. Thank you.
And please come
Doris.
tomorrow for Doris's
Yeah.
follow-up.
Yeah,
Yes.
yeah, we will coming back tomorrow with another awesome workshop. So yeah, stay tuned to it.
All right.
Bye-bye,
Bye.
folks. Thank you.
Bye.